Okay, hello everybody. Hi, AI builders and innovators. Thank you for joining us today. My name is Natasha Berman. I lead the growth and demand gen here at Predibase, and I will be your host today. We'll give people some time to get settled and connected. And while people are trickling in, let me quickly set the stage. What is today's webinar about? As you know, we're living in the age of AI agents. They are boosting productivity in ways we couldn't imagine even a year ago, probably. But with that leap forward comes a new set of risks. Every AI interaction is a potential data leak now. Traditional DLP, well, data loss prevention tools just weren't built for this world. They really can tell the difference between a fake test SSN and a real customer record. And as a result, we get false positives, alert fatigues, and security blind spots at the exact moment when you need precision. So that's why today's session is so important. We are going to explore a new paradigm, how to stop sensitive data leaks in agentic workflows. And at this point, I'll take one quick minute to go over the logistics. As usual, all lines are muted. Today's session will be recorded, and of course, I will upload it to the YouTube and I will share it with everybody. Please take a moment to also participate in the polls. We have a few very interesting questions for you. If you have questions, please submit them in the Q&A panel. We will try to get to them, but if we somehow don't get time enough, we will absolutely answer all of them after the webinar. And I'm excited to dive in with you guys, with our speakers. So today we have Ajinkya. He is a senior research engineer at Predibase, and of course we have Arnav. He is a senior machine learning engineer. They will give you actionable insights on how to build secure, resilient AI workflows with confidence. So guys, take it away.
Thanks, Natasha. And hey everyone, good to see everyone after a while. So for today's agenda, I think Natasha did a really good job of sort of setting the context and giving you a high-level scoop. But the goal is to talk about sort of this new wave of AI productivity boom that we've had in the industry, sort of in the last 3 years, but I'd say even more so in the last year with the sort of growth of AI agents in the industry. And sort of like this tug-of-war battle and between like adoption and considerations to be made in different organizations, primarily around security and legal risks. And there are systems in place to do prevent this kind of data loss and legal issues, and that have existed for a while and have improved over the last few years. But why these systems, in the way that they've been designed historically, cannot keep up with sort of the growing sort of like the way people work with AI tools today. And sort of like their biggest limitation, as we'll see as we go through the deck, is that they are not context aware. And so we need to solve this context aware data loss detection, um, you know, malicious intent sort of detection problems. And sort of solution that we found works best is attacking this problem with small language models. And then finally, what you really need in these systems is highly customizable, highly configurable continuous improvement cycles. And for that, the wedge is usually building a very nice data flywheel. So we'll also go through that. Cool. So with that, let's dive in. So, if you have been skeptical about AI agents, and I'll be honest, I have been for quite a while, I think that the reality is that that skepticism is not well founded. AI agents are definitely here. They're being rapidly adopted in organizations for productivity, for internal tools, for so many more things. And it's because they actually work. Now, they're not perfect, but they do save a lot of time and get a lot of things done for various teams across enterprise. And, you know, if you work in like a large company today or even small startups, you've probably seen that there's three major places where we've started embedding AI agents in our daily workflows. If you're on the software side, you can see that we use a lot of these AI tools for software development and DevOps, so debugging. Think things like cursor agents or augment agents or Windsurf/Codium. They can all take Jira tickets, sort of write code for you in an asynchronous background way, debug it, write tests, write PR descriptions, and like create code that's ready for human review. So very powerful, and you can see teams are shipping code rapidly as a result of this. The second and most obvious sort of AI agent sort of direction we've seen a lot of companies take is this customer support agent. So every tool, especially in enterprise, requires customer support, and there are a lot of companies trying to solve this problem, such as Decagon or Sierra and others, and also each company, like Klarna, is also trying to solve this internally. I guess in their case, the experiment didn't go so well, but um, this is a big area where AI agents are being used. And the third is sort of outbounding and replying to inbound emails, so sales development representatives or BDRs, where a lot of work is being done for discovery, for contacting customers, personalized outreach, figuring out who's the qualified lead. And so these are the three big use cases today, but there's so many more that are being used both um, as very concrete use cases as well as some internal use cases to help automate and speed up things that happen in enterprise. And the problem with this is the rate at which AI tools are being built and being adopted within organizations is is amazing in that it unlocks a lot of autonomy and developer productivity and employee productivity in general. However, there's this constant tug-of-war battle that's taking place in organizations, especially larger ones that have established security and infosec teams. And the the big tug-of-war can be summarized into two buckets. There's this big push for innovation, which is usually coming from both like bottoms up. So engineers, people who work in marketing, people who work in sales, HR, trying to use AI tools to simplify their work and unlock productivity. And then also top down with a lot of leadership sort of pushing, AI first tool usage, AI first tool adoption to basically reduce costs and increase, output per employee, if you will. And the problem is that the security and infosec teams sort of sit in between these two layers, and their job is to make sure that people are productive, but we're doing it in a reasonable way. We're not leaking data that should not be leaked. We're only using things that we should be using. And none of the internal data, whether it's the organization themselves or their customers' data, is being used in any malicious way by these AI tools that are being used within the organization. And so, yeah, there's this tug of war that needs to be solved. And it is a pretty difficult problem, particularly in the case of sensitive data leakage. PII, financial records, documentation, customer info source code, you can imagine. There's so many different touch points. And one thing we hear a lot from folks in infosec and security is that there are a lot of tools, as I mentioned earlier, that sort of try to solve this problem by providing observability, by providing alerting, but they're not very good. And what ends up happening is that all these security tools, like I best summarize it this way, like when your security tool cries wolf 10 times a day on harmless prompts and files, things that are totally safe or not, yeah, totally safe, then you're basically training the teams, so infosec security folks, to ignore the real threats that show up, which may or may not be getting detected. And there's a big reason for this. It's because traditionally, the surface area for where data loss prevention would happen was pretty small and limited. But with AI tools, people are putting in a lot of the surface area has greatly expanded, and people are putting in a lot of content into all these AI tools. Certainly normal for people to now get like a terms of service agreement, take that, put that into ChatGPT and say, hey, can you explain this to me? And technically, there's nothing wrong with it, but it is a lot of sensitive data that maybe should not ever go to ChatGPT at all. So yes, traditional DLP systems fail in these scenarios, and there's broadly one reason. I mean, not broadly, there really is one reason why. It's because the way they're built is very naive. They use complex or sort of like very well-defined rigid patterns or regex patterns, and they can't really tell the difference between, um, you know, whether something is contextually sensitive or not contextually sensitive, or even something as simple as the difference between a real customer social security number or let's say like account number for their banking and one that might be in a fake test file, and we'll see what this looks like in a moment. And so when you have systems that detect things this way, it leads to a lot of what we call false positives, where you flag something as sensitive even though it's not. And I know you're thinking, for a security and infosec team, that's good, right? Like we're never going to miss a case. We're never going to miss a case where, you know, something should have been detected because we're detecting all of those cases, except that if you have your tool constantly screaming at you saying, hey, there's something going wrong, then you're going to feel very overloaded. And it leads to what we call alert fatigue. We've heard this from so many teams that we've talked to, and it forces your, security team to almost ignore the alerts and the noise and the tool entirely, which defeats the purpose of having such a system. And as a result, you'll miss a lot of real threats. So, you know, what does this like why does this happen and how can we solve this? I think it's really useful to take a moment to now step back and actually see what some of these DLP tools do. So here's a very simple example, right? If someone types in my social security or my teammates or my coworker social security is 987654321, that is a totally reasonable thing to flag because it's sensitive data, it's personally identifiable, and it should not make it to such systems. However, the same system will also catch the second case on the right, which is the test server's ID is 987654321. And the reason is the regex pattern that it's looking for is either nine numbers consecutively or a pattern of three numbers dash two numbers dash four numbers, right? And so it's not aware of the context, but it understands what a social security number looks like in traditional pattern matching. And so your security team would be alerted to I guess like a data loss alert in both of these cases. We can also look at something a bit more complicated than this, which is what I would say is a context-aware leak. And in this case, on the left side, you'll see, something like in the attached file, salary details for a confidential project are outlined, right? That probably should never make it to an AI system that is not approved because it has a lot of sensitive data in there, like both the confidential project and the salary details and other things, probably very confidential. But the system will actually detect this um, as, let's say like a true positive. And in the case on the right side, like in the attached file, Sequoia salary details are outlined. Like it will not really detect that it's a confidential project name, maybe something internal you can imagine, like people use a lot of fun names and letters for their teams and projects. And yeah, traditional DLP systems will miss that. And we've seen this a lot with a lot of systems that we've played around with a lot of open source tooling that exists around PI detection. And so we need something that is better than this. And to summarize what we've kind of gone through so far, you know, AI productivity is increasing from the advent of AI agents, and there are systems in place to make sure we can balance growth of innovation with staying within the bounds of what is good security practices, legal practices, so that you don't leak sensitive data. However, those systems have worked well historically, but are not working well because the types of ways these tools are being used are changing very rapidly. And so the old rule book is broken, and we really need to explore a new approach. And with that, I'll hand it to Ajinkya to walk you through how we're thinking about it.
Thanks, Arnav. Let me share my screen. Is that? Okay, found it. Yeah, I hope you can see my screen. So it's nice to say, oh, the old thing is bad. It doesn't work. It is rigid. It has this problem, that problem, right? But as soon as you try to do something new, it's a wild, wild west that you are stepping into, right? You don't know what's going to happen, right? And well, at least in this case, we have these things called as LLMs that at least work really well. And they are these amazing things that can understand random things from context. And they've even convinced everyone that AGI is just around the corner and all of our jobs are gone, right? Yeah, well, good luck with that, right? But it's expensive, right? It costs, like if you were to use OpenAI models to do something like the previous rule-based engines that used to do, the amount of queries that they used to process, you would easily run up a bill of $1 million per day, right? And extremely expensive. And then the latency, right? It's not fast. Like you can apply a regex in milliseconds, right? It's extremely fast. But O1 will take you 17, 20, 40 seconds to answer your query because it sits there and thinks like a man. Well, that's not going to work. We need to reduce the latency because the amount of queries that you are trying to process in this system is very large. Think about a 2000-person enterprise organization where if we believe that agents are the future, where everybody is going to have a few agents working for them, then think about the volume of data that is being generated, right? And think about how much data you have to analyze for leaks, for all sorts of sensitive information, right? So you can't think for 20 seconds, right? You have to have a system that works in the order of sub-milliseconds or like even at least milliseconds, right? So these are the two requirements. It has to be cheap and it has to be fast because it has to process a lot of data, right? And it has to be accurate. It has to understand context. It cannot be hard coded like the previous rule based systems where otherwise you haven't gained anything. Uh, yeah, we need more efficient and specialized solutions. Enter into the picture small language model. All you have changed is from large to small, and everything is magically nice in this universe. So why are SLMs better? Well, first of all, SLMs are small, so they are efficient. They are very fast. You can run them on smaller GPUs. They don't consume as much electricity. You can put them in any random data center you can find. You don't need to get like the state of the art data center that has liquid cooling and stuff, right? You don't need many resources. A poor person can also run these SLMs, right? And they are not just cheap, right? They are also precise. And now you may be wondering, well, LLMs, why do you need large language models then? Why can't SLMs? Well, there is a catch. You need to fine tune them. Unless you fine tune, they're not great. But once you fine tune, they become domain experts, right? Whichever you have, you are Pepsi, and your goal is to ensure that everybody has their sugar water, right? Then you have your own data, right? That you have internally, and you can train your Pepsi small language model that knows all about how to make carbonated drinks, right? So this way, because you're tuning that model on your own data, you can reduce the false positives, you can increase the accuracy of the systems. It's more precise, it's more efficient. That's not it. It's also more secure because unlike OpenAI's GPT-4, O1, O3, whatever, right, GPT-5, right, where that model runs in OpenAI's cluster, and you have to take your data out of your organization, send it to OpenAI, and cross your fingers and hope that OpenAI doesn't mess with your sensitive data. It doesn't use it for some nefarious purposes or like uses it for training, where somebody can just extract that out of the model. So you can take those LLMs, host them in your own cluster, run them however you wish, or as long as you wish. It's cheap, it's efficient, it's secure, right? But the key thing is you have to tune your models, right? So you have to train your models to tell you accurately what is sensitive and what is not. So how do you do it? Well, the first step is you gather a bunch of data set, right? And here we are just talking about like traditional PII detection, which is SSN, email IDs, what have you, right? Now, previously the approach was that you would have regexes that would just look at everything that's SSN. But as Arnav showed earlier, not everything that looks like an SSN is an SSN, right? You want contextual information. So what you do is you take your sentence, whatever that is, right? You give it to the model, and for each token, you get a classification result. The model will tell you what is it. O if it is not PII, it's like some other category, or SSN if it thinks this is an SSN, right? So token classification, right? And so you get these tokens, and then you train a linear layer, or you train the classification head to on a platform like Predibase to predict these labels, right? So this 1, 2, 3, 4, 5, 6, 7 looks like an SSN. The model should predict whatever tokens that get assigned to that particular number as SSN, right? Once you have this model, you can run it and you can detect contextually aware very robust sort of social security like PII detection, right? So that works great. But now you can even go further and say, oh well, it's great that you're detecting SSN, but SSN is not it's not the like the PII is not the entirety of sensitive data that an organization has, right? There is a lot of data. For instance, you might be working on acquiring some company, you might be selling some of your assets, and that needs to be private. You can't let that information leak because that is material information that could affect stock price if the company is public, and then you could get into trouble with SEC, right? So there are some things that are not supposed to leave the bounds of your organization, but because these LLMs are very similar to humans, um, like the stuff that you would talk with another colleague or like your boss, you're not chatting with ChatGPT, right? So you're sending all sorts of sensitive information, and that cannot happen. You have HR documents which contain sensitive information about payroll, performance reviews, how the teams will be reorganized, and whatnot, right? So all of this data it's hard to define. There are no rules. For SSN, at least you can devise a rule, but here you can't even devise a rule, right? And these are fuzzy things. These are heuristic based things. Like if I give you a document and tell you that any document that has merger and acquisition related legal stuff in it, classify that as sensitive, and we are not going to let anything from that document leak outside, right? So that's the problem that we're dealing with now, which is extremely fuzzy, non-determinist, like hard to define definition of sensitiveness. So the first problem is the the definition of what is even sensitive. So we're going to simplify things. So the way we are going to say simplify is this setup. You have a user who wants to run this prompt and run this prompt on these AI tools like Gemini, whatever, right? And as an organization, you have a bunch of data that you have backed up with Rubrik, right? So Rubrik has access to it. So what you could do is then you could take that data and you could sort of organize it depending on the classification, like the sensitivity level. You could run, you don't know how. Let's leave that out for now. Some way you can take all your data and partition it: sensitive, non-sensitive, sensitive, non-sensitive, sensitive, non-sensitive. And then anytime a user sends a request, you are going to run it through two different models. The first is the PII detection model that we saw earlier that tells you SSN or not. That's the basic model. And then you also want to do context-aware detection, which is this prompt coming from a sensitive document or like that, right? So what you do is you create indices out of your data backups, right? And you take your prompt, you run it through, like you also chunk it, and you try to find a very deterministic non-LLM based matching algorithm, right? To see the if the prompt contains some portion of the data from the documents that you have deemed sensitive, and then you pass it to a sensitivity detection classifier that's going to tell you, oh, is this really sensitive or not? And then you take that and you make a decision. Is this prompt safe enough to be sent to AI tools, right? You combine the output of these two models, and then you can, if everything is kosher, you can send it to the AI tools. Otherwise, you're gonna show a pop-up to the user. Is this good? Is this not good? And the user can also like raise a request saying, oh, this is good, but why is it getting flagged, and such things, right? Yeah. So this is great. But now, how do you train this sensitivity classifier, right? Like how do you even figure out which documents are even which chunks? Now you can even go a step further and ask, oh, I just like maybe a document is deemed sensitive, but the contents, like not all of the contents inside the document are sensitive. What if this is like a boilerplate contract for which most of the text is publicly available, everybody knows, but then there are sections that are very specific that contain sensitive information. So a document could be sensitive, but inside even that document, some of the chunks may not be sensitive, right? And so we would like to even go deeper and analyze that. So you take a bunch of internal documents, you chunk them, and you assume that your strong LLM is the oracle, right? That is the source of your ground truth. So you give all the chunks in your document to a strong LLM and just ask it to classify sensitive or not sensitive. And of course, this is not the best way to do it. The LLM is going to make mistakes. There are going to be false positives. There are going to be all sorts of problems, right? But at least like we are attempting to solve this problem, which on the outset doesn't even seem like it can be solved, right? And then you can have a person. So the strong LLM, while the label generation process is noisy, it allows us to filter out all those chunks that are definitely non-sensitive or chunks that are definitely sensitive. And then you can focus on the boundary conditions where the LLM is not really sure, is this sensitive, is this not sensitive, right? So you can take those samples, give it to a human, the human can review those, and now you have like a good data set that you can train an SLM on, right? And so earlier you used a big LLM. This was a costly process. You did do it once. Then the human review is also expensive. But once you put all that knowledge into an SLM, you get a small, fast, secure thing, right? That you can run on as much volume as you want. Well, there is so we are now at a really good stage where we have an understanding of which documents, like which chunks inside documents are sensitive, right? But the the cost of getting annotations from humans is very high. Like you could even like you can imagine running a strong LLM. The cost is just money. But with humans, the cost is expertise and like hiring the right talent and all sorts of things, right? GPT-4 is always available. GPT-5 is always available, right? There is no, yeah, it's rate limited, but it's always available. So, what are the ways in which we can make this system more dynamic? Like a security engineer or the person whose job it is to monitor uh, the the landscape of interactions that people in an enterprise are having with AI agents, right? That person can come and just start looking into things. Like I think they can start first they can start build some like basic rules. Oh, I think uh, this sounds like it should be sensitive. Are there such instances, right? So you take a bunch of users who have done some things with AI tools. You can't block everything, and so you let users do whatever they're doing, and then you gather an interaction history, right? And now you go into this discovery phase where uh, the security engineer describes the kinds of patterns that they may be interested in natural language, and then the LLM takes care of taking those rules, compiling them using keyword search or like some sort of filtering, and runs those on the interaction history. And you get a few filtered out report that you can present back to the security engineer, right? And the user is going to review this thing and give feedback in terms of, oh, okay, the things that you flagged look good, things that you flagged don't look good, this doesn't make sense to me, right? Then you either modify the rule, you come up with a new rule, or like the feedback itself is used by the LLM to improve its rule, right? So automatically. So you can design all sorts of these systems where it's more iterative, it's more playing around with interaction histories to figure out if there are any uh, patterns that are bad and you don't want them to happen, right? And this way, you have now a data flywheel going where uh, each new additional rule reduces the amount of annotations that you have to do, and or the system keeps becoming better and better over time with more uh, interaction. Right. So that's all. We at Rubrik have been really interested in these areas. We have been exploring a lot of things. And one of the things that we are really interested in exploring is this thing called as agent rewind, right? Where you have a bunch of these agents running amok in your enterprise and you don't know what they're doing. They could be doing some bad things, good things, hopefully. But what if they do bad things, right? Then, and they, I heard a story where some agent just deleted production database of some company, right? You don't want that to happen. You're going to lose customers. So what do? Agent Rewind is there to help you. It's gonna keep track of what actions agents are running. It's gonna correlate them with what kind of backups that we have, and hopefully get you to a stage where the agents' bad actions can be reverted, and you're back into a zone where things were kosher, right? So check out this QR code if you want to know more. Yeah.
Cool. Thanks so much, Arnav and Ajinkya. Do we have some time for the questions? I think I
Yeah,
saw it all.
I think we can take a few.
Yeah, so just really quickly, there was a question about the slides. I will share them after the webinar together with the recording. And now to the real questions. So there's a question about, can you please share any quantification metric summary for LLM call, if you have any?
Yeah, I think I'd ask for some more clarification on the question, but I'm happy to take a first stab at Jinkya chime in. So if we're talking about like what would good metrics look like for a system like DLP detection system, you can imagine that you want your response time to be within 100 milliseconds or lesser, ideally 50. The reason, yeah, between 50 and 100, the reason is that anything more than that will be felt very actively. But if you think about, Ajinkya, can you go back 2 slides maybe? Maybe like the main DLP one, like the one, this one. So if you see like where the system sits, it sits between the prompt and your AI tool. So you need it to feel really fast and snappy and so be accurate. So yeah, typically you want, I'd say like between 50 milliseconds or 100 milliseconds is like good response time. If you think about traditional system design for a lot of enterprise software, like you usually want end-to-end response times to be within 200 milliseconds. So that's probably your uppermost bound. And because of that, you have to be very smart about the types of models you create. So size, how they're deployed, so the hardware, where they're deployed, so like network latency is low. And lastly, what they output. And the shorter the output, the faster it'll be. And yeah, that's how I'd probably answer that question. Ajinkya, anything to add?
No, I think.
Okay, so we actually have a hackathon also going live, so I think we have time for 2 more questions. All the others we probably will take offline and just reply to you by email. Okay, so the question is, do you recommend the strong LLM be internal LLM? Ways to classify internal docs. Well, I think what is meant is for, for sensitive internal documentation, would you recommend using a powerful internally hosted LLM to act as a classifier? I hope this is what is meant.
Think
If the goal is to route documents to smaller specialized models without
makes sense.
exposing.
Ajinkya, you want to take that one? Okay, they
Yeah,
confirmed.
yeah. So
But
this is my favorite topic. Like if you could run however big LLM you have in your own cluster or like on-prem, like or on even laptop, right? You don't need all this fancy DLP stuff. Like why do you need it? Like your data is never leaving your organization. But that's not likely going to happen. There is a lot of stuff that goes on top of these LLMs uh, that you need to do. And so, but the nice thing about classifying internal docs is you might not really need all the product stuff that happens on top of these LLMs, right? So yeah, that's great. That's one use case where you can just use strong LLMs, host them in your cluster, and you can use those to classify internal docs. You can do a lot of stuff, right? It's going to be costly, but you have security guarantees. You don't have to make a trade-off. If I want to use a strong LLM, you don't have to trade off security because now you have to send data outside because yeah, so that's actually a good point.
yeah, I might also add that the only other trade-off I can think of is you still have to pay the latency burden, even if it's hosted securely. So you could distill and host a small, strong LLM within your organization for the same thing. Yeah.
Got it. Thanks so much, guys. Okay, let's do the last one and wrap up. So the question from Lalit. The big challenge with all the new attack surfaces in this brave new LLM world is API corruption. can SLMs be trained to track API discovery, observability, etc.?
Yes, so that's Lalit's question, right?
Yeah.
I think API corruption is not, it's not immediately obvious to me what that means, but can SLMs be trained to track API discovery observability? I'd say that there's two parts to this answer. I think LLMs by themselves may not be the smartest engines to figure out API discovery, but they are very good engines for observability. And what I mean by that is that analysis, especially on big data, in cases where you don't know what you're trying to analyze a priori, is it's a hard problem. And actually, I think he has been working on this for the past week and a half or so, which is how do you actually use LLMs to effectively learn about what's going on in such systems? I think API discovery, like maybe more broadly put, like what you really want is an observability system that can see all agent calls, that can see what each agent's doing, like the full water flow of end-to-end calls. So all the tool calls it made before returning a response. You want something that can track whether certain actions and tools are risky. And you want to have observability at all of these levels. And I think I'd say like LLMs by themselves are not good enough to do this, but you can have an LLM in the loop to help enable these things. And yeah, these are areas that we are certainly also exploring. So if you're interested in learning more, please reach out and we can chat about it.
Amazing. Thanks so much, Arnav. Well, thank you guys, Jinky and Arnav, for walking us through so much interesting information. And I guess I will let you get back to the hackathon. Thank you, everybody, for joining us today. If there's one thing we hope you take away, it's this: AI agents are powerful, but without the right guardrails, they can become risky very fast. With the right approach, context-aware detection, fine-tuned SLMs, and resilient workflows, you don't have to choose between innovation and security. So to wrap up, I will be sharing the recording. I will be sharing the slides. Thank you again for spending part of your day with us. And until next time, stay curious and keep building secure AI. Bye, guys.
Thanks all.
Bye, people. Bye.